Good morning, everybody, and thank you for joining us today for this webinar introducing the latest addition to the Rigaku wavelength dispersive XRF range, the ZSX Primus 3 Next. My name's Gary Smith. I'm product manager with SciMed, and I'll be hosting and chairing today's session. For those of you who may not be too familiar with SciMed, I'm going to take a couple of minutes to introduce ourselves, Rigaku, and the XRF product range before we get into the main presentation. So who are SciMed? Well, we're one of the UK's biggest distributors of high-value lab equipment, providing UK sales and support for a wide range of manufacturers. We supply equipment for process chemistry, such as high-pressure reaction vessels, ultrasonic processing, and supercritical CO2 extractions, elemental and molecular analysis techniques, including XRF, but also ICP, atomic absorption, and infrared, materials properties testing solutions, such as oil testing equipment, thermal analysis, and powder flow testing, and process safety testing equipment. All our product managers are experienced and expert in their fields, which means we place a strong emphasis on the science and providing technical support to our clients. Our suppliers include a number of globally recognized manufacturers. The map and list that I've just pulled up shows these and where they are based.
Je veux résoudre la...
So today we're focusing on Rigaku, which I've highlighted in red. As many of you will be aware, they're a global manufacturer of X-ray fluorescence and X-ray diffraction equipment, with two primary manufacturing bases: Japan, which is the production site for wavelength dispersive XRF, and the USA, which is the production site for energy dispersive XRF. SciMed have been the UK distributor of Rigaku XRF for 15 years. And over that time, we've built up a lot of experience and expertise with their products. So a little introduction to Rigaku now and their wavelength dispersive XRF product range. Rigaku were founded in 1951 and have been manufacturing wavelength dispersive XRFs for over 50 years. During that long history, they've introduced many innovations and industry firsts in commercial X-ray analysis. So it's fair to say they're one of the biggest global manufacturers in this industry. Let's take a quick look at the Rigaku wavelength dispersive range. We have a wide variety of specifications, which cover all analytical requirements, from relatively simple benchtop units through to high-power sequential and multi-channel simultaneous spectrometers. So working from left to right, we start with the MicroZ ULS. This is a single-channel benchtop system designed specifically for measurement of sulfur in oil and petrochemicals. This is for compliance with industry standard methods like ASTM D2622, where wavelength dispersive XRF is the stipulated technique, but sulfur is the only element of interest. Next, we have the Super Mini 200. This is a compact benchtop sequential spectrometer with elemental coverage from oxygen right through to curium. It uses a 200-watt X-ray tube, and the advantage of this system is that we get this very wide elemental coverage from a completely self-contained unit, which doesn't need any external services other than power and P10 gas for the detector. Next, we move to the high-power sequential systems, starting with the Primus 3 Next, which we'll be talking about in more detail later. This is a 3 kilowatt high-power system for analysis of samples in vacuum, which is ideally suited for industrial process control applications. We then have the Primus 4 spectrometers, the Primus 4i, which is a 4 kilowatt high power system with optics below. The Primus 4 systems, the 4 kilowatt systems, add benefits in terms of sensitivity, improved sensitivity, and also additional features, optional features such as sample mapping and small spot functionality, as well as the ability to purge the atmosphere with helium and measure with a helium purge atmosphere for liquid analysis. So the Primus 4i is ideal for high throughput liquid applications. Also has a very small footprint, one of the smallest footprints of any 4 kilowatt spectrometer on the market. The Primus 4 is the sister spectrometer to the Primus 4i, 4 kilowatt with the same functionality as the Primus 4i, but optics above. So that brings in the improved benefits of optics above, such as reduced risk of sample contamination from sample spillages. And finally, we have the Simultix 15, which is a large multi-channel simultaneous system, which is ideal for situations where we need ultra rapid process control. So it's a very high throughput environment where sample testing turnaround time is very, very important, and this will measure multiple elements simultaneously with WDXRF configuration. So today we're going to be focusing on the ZSX Primus 3 Next, which is Rigaku's latest addition to this wavelength dispersive lineup. I'm now going to introduce our presenters, starting with myself. I joined SciMed some 11 years ago now, and I've been working as applications specialist for XRF in that time. I recently moved into the role of product manager. We have with us today Paul de Pape. Paul is the wavelength dispersive product marketing and business development manager for Rigaku Europe. Paul has extensive experience, over 30 years experience as an XRF user, applications scientist, and a product marketing manager with Rigaku and other companies. And he joined Rigaku over 10 years ago and has performed varied roles in marketing and business development for the company during that time. Paul has extensive experience in a very wide area of expertise. And finally, we have Carmen Kaiser-Brugman. Carmen is Rigaku Europe's XRF applications specialist. Again, she's a very experienced analytical chemist with many years of industrial experience, particularly working in the cement industry. So between us, we have a significant amount of experience working with XRF applications. I had a little look earlier, and I think between the three of us, we have about 75 years of combined XRF experience. So hopefully we'll be able to answer any questions that you may have for us at the end of this webinar. So moving on to today's agenda and the webinar itself, we're going to start off with a technical presentation from Paul de Pape. Paul will then hand over to Carmen, and Carmen will provide us with a live laboratory demonstration of the Primus XRF system and the software. And then at the end of the session, we will come back to myself and I'll share any questions and answers that you may have for us. Just regarding questions and answers, from a little bit of a housekeeping point of view, if you have any questions, just type them into the Q&A box. If you click the little Q&A icon on your Teams taskbar and just type your questions into the Q&A box, I'll collate these and then we'll go through those questions at the end, and hopefully we'll be able to answer any questions that you may have. So without further ado, I will hand you over to my co-presenter, Paul de Pape, who will perform the first presentation, the technical presentation. Over to you, Paul.
Thank you very much for the introduction, Gary. So 75 years altogether. You surprised me really saying this number. But anyway, that's the way it is. We're getting older, obviously, but therefore also more experienced. And that's the positive thing about life, I would say. Hey, everybody, welcome to this webinar. ZSX Primus 3 Next is indeed our latest X-ray spectrometer, WD XRF spectrometer. and we will have just some technical look at it, going in some details, tell you what benefits you can get from this excellent spectrometer. So if you ask me to mention it in a few words, what is the ZSX Primus 3 Next? Why should I buy it? Then this is the phrase that we came up with. So it's a high-end, tube above industrial WDXRF for the analysis of solid samples at an affordable price. And that's really what the story I'm going to tell now is about. So it's really, it's thought for the industry. That's the main thing, really. So what are the main features we have here? So it's high-end for industrial environments. It has an increased reliability because of the tube above configuration, and you will see this has really some huge advantages. We can analyze from beryllium to curium. We have a special guidance software, the ZSX guidance software, which helps you really easily in setting up applications or other types of methods. We can also do high-speed analysis. We also have improved our service and application support possibilities. We can do data sharing. This means in between the same kind of instruments, we can share data. You can also share data directly with Rigaku or with the service department. And we have, of course, the attractive pricing. Our focus, or the markets we like to focus on, are very industrial, as I have mentioned before. But one thing I have to say, as it is intended for only solids, we do not analyze any liquids like petroleum. So ZSX Primus 3 Next is not intended for those applications. All the rest, all the other solids we can easily do. Let's have a look at some hardware features and the benefits that you get from it. So first of all, we have the tube above optics. So what is the main advantage we have here? It is that as we have the tube above our sample, we will not be able to contaminate the tube window in case of a sample breaking. And that's, of course, very important. If you have the tube window being contaminated, we lose, of course, intensities. A service engineer may have to come and make the tube window clean again. So having this tube above, we reduce the downtime considerably. The X-ray tube that we have is a 3 kilowatt X-ray tube, and it has an especially relatively thick tube window. It's 127 micrometer, and this is because the system is intended for industrial use. So we want to have a very solid X-ray tube with a long lifetime, a tube that can really stand the hardest kind of environments. So, but we can still go up to 60 kilovolts, up to 100 milliamps. And we use also a tube aging. So in case the equipment was switched off for a longer time, tube aging will take care that you assure the longest tube life possible. And also various security mechanisms protect against irreparable damages. So after the X-ray tube, there are placed the X-ray beam filters. And X-ray beam filters are used to, first of all, improve the peak to background ratios to, let's say, reduce the limits of detection, but also to remove disturbing X-ray tube radiation lines. So we are talking about a rhodium anode, and these rhodium lines can appear in spectra. If we want to analyze elements like rhodium, by means of filters, we can get those lines out of our spectrum. Sample throughput is also something we have very detailed been thinking about. So sample loading is quite easily being done. So we have a high degree of accessibility into the sample loader. So we have an 48 position sample or automatic sample changer. We call this ASC, which you can open by means of a drawer or by means of a door. And in that ASC, we can put up to 4 sample trays, which can each contain 12 sample cups, so 48 in total. So you can visualize at any time what is happening inside the sample changer, just to undertake some action if something would go wrong. One never knows, of course. We are using a mechanical pickup system, and this assures really state-of-the-art sample cup loading. So no pressed air, mechanical way is the best way to grab the sample cups. And we have, of course, built in the necessary mechanical safety circuits to stop any mechanical movement if something would go wrong within the sample loader. Important to know is that we have a dual sample loading position. This means we have two positions. And as one sample is being analyzed, the other sample is already being loaded. So we have a dual vacuum pump system. This means that we use one vacuum pump for the spectrometer chamber and the other vacuum pump for the pre-vacuum chamber. So we have at any time our X-ray tube switched on, and this is of course very important to increase the tube lifetime. And we also have, of course, sample sensing function. So in this dual loading position tool, we have sensors that detect if there is a sample cup present or not. Sample cups can contain samples up to 52 millimeter in diameter and up to 30 millimeter in height. And we have, of course, also a sample spinner that takes care for averaging eventually heterogeneous sample surfaces. And once again, we have the tube above, so we have the irradiation of the upper surface, which avoids contamination of the spectrometer. So after the sample, we have diaphragms and also an attenuator. So we have 4 sample masks, which go from 35 to 10 millimeter. And we have also one attenuator. And what is now the advantage of this attenuator? So we ideally want to use our X-ray tube always on the same power. This is the ideal. But sometimes, of course, we have samples that contain one element or 2 elements that have a higher concentration. Thinking, for example, about iron ores or steels, which have a high amount of iron, maybe chromium, nickel. So we can use this attenuator to reduce the intensities. And we can see on the right picture below, if I would use an attenuator or not. So the gray scan really shows a detector signal without using the attenuator, so we can clearly see saturation of the detector. And then with the attenuator, we can observe a very nice peak. So this really helps also to keep our system stable, but also to improve or to reduce really our measurement time. So basically, we can offer 3 collimators. We have positioned for 3 collimators, which come after the sample masks, of which 2 are standard, and we can have one additional one for those who want eventually to analyze light elements from beryllium to oxygen. After the collimators, the slits, we have our crystal mill. We have a 10-position crystal changer, meaning we can analyze a wide range of elements, or thus a big range of applications. 3 standard crystals are in there, the LF200 PET crystal and RX26, which assure the analysis of oxygen to curium. And also this crystal mill is bi-directional driving. This means you do not lose time having to let the mill turn at any time in one direction. So we can let it turn in any direction, left or right. So we have 3 basic crystals as mentioned, and then we are using natural crystals like the LF200, like the PET, like the germanium, or we use homemade, Rigaku-made artificial crystals, which are all indicated with RX. And we can see using those artificial crystals, we can go down to beryllium for our elemental range. After the crystals, we come to the detectors, 2 standard detectors, 1 scintillation detector, 1 flow counter to detect the full range of elements. What is important in the flow counter, we have a central wire cleaning, and the central wire cleaning we can activate through the software. So we do not need to open this detector to exchange the wire. And this is a very big advantage if you want to have a reduced uptime of the system. We also use a gas density stabilizer in this flow counter for increased measurement stability. And optionally, one never knows if there is someone who cannot easily obtain P10 gas, you're somehow maybe remoted, then we can also offer a gas shielded proportional detector. In that case, we can go down to oxygen. 2 detectors, So analysis speed is really one thing that is important. We have now built-in digital multi-channel analyzers, which contain 1024 channels. So this really stands for high-speed analysis. This means we measure all the incoming photons at the same time. So data is really obtained in a few seconds. And this, of course, improves the accuracy of the analysis because we have an increased counting linearity. So for our scintillation detector, we have a linearity of up to 1800 kcps. And for the flow proportional and the gas seal detector, we have a linearity of up to 3000 kcps. This means we can catch really many photons. This automatic center wire cleaning, I want to highlight a little bit, because if you need, let's say, to do your pulse height analysis and you can see that, well, the energy distribution is not that nice anymore, it can be because this anode wire, which is in the middle of the detector, is dirty. And if it's dirty, it needs to be replaced, or as Rigaku does, we put the high voltage through this wire and we clean it automatically. So we do not have to open the spectrometer. We do not have to build out the spectrometer, open the windows and exchange the anode wire. We don't need to do all this. So it's a matter of 5 minutes and we can clean the anode wire. So instead of losing 1 or maybe more days just exchanging this wire, we can do this in 5 minutes, meaning uptime, of course. Analysis speed. So we have improved the sample throughput by high speed data processing, but also by efficient control of each drive unit. So what does this mean? We have one example here, 16 elements in a cement sample, where we could observe a reduced measurement time of about 20 to 21%. So in our former model, we can see here the time that we needed to bring the sample in the measurement position, the sample measurement time, and then to bring the sample back out of the spectrometer. So now with our ZSX Primus 3 Next, we can do this in about 20% less time. So we can see reduced measurement time. And this is, of course, very important. This is just because we speed up the drive units, the crystal moving, the detector moving, and so on. Some other relevant hardware specifications which assure an optimal uptime of the spectrometer. So we have a directly coupled vacuum pump with a backflow prevention. So if this backflow prevention wouldn't be there, it could, for example, happen that all of a sudden you get some pressure change, which would make the window of the detector break, for example. We also have a powder sample attachment. So in case some loose powder floats around in the spectrometer, we have a filter that takes those particles. We have a temperature stabilizer that avoids analytical fluctuations, especially for the light elements. And then we have automatic unloading of specimens in case, for example, the system breaks down, which could eventually happen, or the electricity has gone. So the software will recognize, oh, there is still a sample in there, and it will automatically unload the specimens in there. And in case the ASC, the automatic sample changer, is down, we can always manually load samples. So you're really never without the system not functioning. So after the hardware, we have a closer look into some software features and its benefits. So we are using the guidance software, and this guidance software provides a very strong user support, as we can generate automatically calibrations and its conditions to analyze. And it's both experienced user as well as inexperienced or beginning users that can have benefits of this. We also have a software integrated for the day-to-day analysis and service or maintenance purposes. And this ensures, of course, user friendliness and uptime, because you can do basic service yourself. And then we can also define different user levels according to the operator's experience. So beginning users may maybe want to have a beginning user level, so that they can maybe just start measurements, and a more advanced user can do anything that he wants to do. But we will go through all these functions now one by one. the guidance software. So it's very intuitive. If you want to make a calibration, for example, we see a flow bar method. We go from top to bottom. So the first part is putting all the information you have about your sample, elements you want to analyze, sample preparation methods, concentrations. After that, we will define the measurement conditions, define peak and background angles, perform PHA analysis, and then we can run our standards and drift correction samples, and then we can make the calibration curves. So for someone who has really no experience, the only thing you basically have to do is to fill in the sample information, and then you can just scroll down through this flow bar, and at the end, you will get the calibrations automatically done. The PHA window is, of course, something important. It's the pulse height analysis window. It's an energy distribution. And this is using this DMCA. Using this digital detector, so energy distribution windows can easily be changed. So as we are analyzing all the energies at the same time, we have all the energies within one window. So we can easily change the settings of that window. And this is for people who have already done this, they may understand that it is a big advantage instead of having to re-measure each PHA again after having changed the parameter. This is not necessary anymore. So what does this mean? By means of an example, so phosphor in a copper alloy. So phosphor has a changing concentration as well as copper. So if we now look in the PHA window down here, we can see huge copper peaks at the right, and those copper peaks may disturb the analysis of phosphorus, and especially when the concentration of phosphorus is low. Now, depending on the window that we are going to set, we can see here at the left the LL, which is the lower limit. The upper limit isn't visible here. But anyway, so we can change those levels. And depending on how we set the window, so on the right-hand side, we can see a calibration curve using a 150 to 300 window. We can see quite a high background here and an accuracy of 33 ppm for the phosphorus, which is low in concentration. If we use a PHA window 150 to 250, we can see, first of all, a much lower background. So we are really reducing the influence of copper, and an accuracy of 2 times lower, so 16 ppm. So calibration curves can easily be changed simply by changing this PHA window and without having to do an additional measurement. The user access levels, so depending on who the user is, the administrator of the system can define user levels to avoid human errors like changing or deleting eventually calibrations, which frequently happens. Believe me, you can edit analytical results, or you can also avoid unwanted service actions. We also have improved somehow the reliability of the analytical results in that sense that for each measurement, we have now introduced also the standard deviation of this measurement, or you can really see the precision of the analysis. So if you have like iron 53.62%, we know that the reliability, the precision of the analysis is like 0.043%. So this is a big advantage because you have directly a precision check of your result. And this we can see in the table below. So if we have now one single measurement, we calculate the standard deviations, or the software really calculates the standard deviations, or we compare this to a 10-time repeated analysis of one and the same sample. So we can see that the standard deviations, look at, for example, manganese, 0.023 in one single measurement, or 0.0027 for 10 repeatability analysis. So we can see that the standard deviation that the software calculates is really very precise. We can also see some spectrometer parameters in the results view. So analytical results may depend on some parameters of the spectrometer, like the vacuum, the temperature, the detector gas flow rate. The software will now show those parameters into the results window. So you can quickly see in this window if one result may be out of specification because of one of those three parameters. So if we look here, for example, at the row number 2, We can see, oh, something was wrong here. It was not the temperature. It was not the pressure. Oh, we can see the P10 flow rate. The gas flow rate of the detector was out of limit. So something may be wrong with the results. So this also is very helpful just to find out, yeah, if a result is out of specifications, why could it have been? Also, detection limits are now being calculated automatically. So first of all, in the calibration curve, we can directly see what the detection limit is. In this case, we see here a phosphor calibration curve, and here we can see the detection limit. And also for each individual standard, the detection limit is being calculated. So detection limit is not really something that is specifically for an element. No, it is specifically for an element in a certain matrix, but also for an element in a certain standard, because not all standards have the same composition. So therefore, the detection limits may differ depending on the standard composition. So it is much better to evaluate your results. So you have really a good idea about what is the true detection limit of the method and for a sample in a certain composition. Efficient daily analysis management. So very often before you start your analysis, you have to do some preparing analysis, like you have to start up maybe your spectrometer, you have to do a pHa measurement, maybe you have to do aging of your X-ray tube, you have to do quality check measurements, you have to do drift correction measurements. So you can predefine all those measurements on a daily base, weekly base, monthly base, depending on how your routine work is. So this means before you start your working, maybe you start working at 8 in the morning, maybe you start working at 6 in the evening, you can already prepare your spectrometer such that all those analyses have been done. So you can directly start with your routine analysis. Now, if your company decides to purchase a spectrometer of Rigaku, which I think is a very wise idea, so this can be a central plant which has one of our ZSX Primus series spectrometers. So this spectrometer is there, and other sites, other plants of your company decide to also purchase a similar spectrometer. It doesn't have to be the same spectrometer. Still, it needs to have the same instrument parameters. So you can really copy from one system the calibrations to all the other sites. So it means that you have really the big advantage that you do not need the same intelligence in each of your plants. So you can easily copy calibrations that have been done in the central plant, reducing, of course, strongly the workload for the users, which have some less experience. So this will, of course, increase the efficiency. And we have also a data pack function built in the software. And this data pack can be used in case there is some trouble with results, with calibrations. You can make a data pack, send this to your local Rigaku, or in your case, SciMed, and the local specialist will have a look into those packs and see what is the problem, what is the situation, and then send you back the information, or eventually provide the application prepared under the right conditions. We also have some pre-calibration packages, and for the Spectrometer series ZSX Primus 4, Primus 4i, Primus 3 Next, and also for our Supermeter 100, we have some application packages available. And well, depending on what your applications are, you can, so to say, have pre-calibrated packages, meaning the calibration is already installed in the laboratory in Japan where we produce the spectrometers. Or you can also have calibration packages, and these are packages where you get the standards, where you get all the needed parameters for setting up the calibration, and then you just have to analyze basically the standards and calculate your calibration lines, and you have things up and working from the very first day you have the system installed. Two examples of such pre-calibrated packages is the Oxide FP pack and the GeoTrace pack. And both are really intended, as you may probably understand, for mineralogical samples, geological samples, The oxide of BPAC exists of 23 oxides in a very wide concentration range. The geotrace pack is for 26 trace elements and 9 major oxides in mineralogical and geological samples. The geotrace pack uses pressed pellet sample preparation, and the oxide of BPAC uses the fused bead sample preparation. So it's not the intention to explain why fused bead, why pressed pellet, why those elements. This we can tell you in a different webinar, or we can just be contacted and explain you directly. But these packages are pre-calibrated, so ready to use after installations. So you have seen our portfolio before, and I highlight here the ZSX Primus 3 next a bit compared to our other products. So what is the position of the ZSX Primus 3 next compared to our other positions? So it is really intended for the key markets: mineral mining, cement, metals. So typical clients could be mining sites, cement, metal production sites, but of course also other like chemistry plants or whatever. So highlights are here. We have the tube above. We focus on industrial and solid samples, speed of analysis, and of course also the price. So to summarize, the ZSX Primus 3 Next is really your partner for fast and reliable production control in a highly demanding industrial environment. So after our practical session, which my colleague Carmen will now start, we are ready to answer your questions that you may have. Carmen, the stage is yours.
Thanks a lot, Paul, for the introduction. Welcome to our application lab here in Germany. I will share my screen. So welcome to our lab in Germany. This is our Primus series of instruments, and I'd like to just show you a little bit on the instruments, followed by a few sections on sample preparation, because this is one of the most important parts for you, and also to show you some unique solutions that we do have at Rigaku. And then I will end off with showing you a bit of the software to show you how intuitive and user-friendly it is. So this is our Primus instrument. It's very easy to load samples. So you have a door that can open from the side. You also have a drawer that can be pulled out, and you can place your samples in here. We also have removable trays that can be placed in the lab for easy loading, and you could bring it to the instrument. We also held us a lot about the instrument in terms of its instrumental conditions and parameters. But one of the most beneficial things for you is that this WD X-ray has an X-ray tube above your sample. So this is a big advantage because, of course, we do not have any broken samples or dust falling on top of our X-ray tube, which usually can be a problem for industrial customers. When we prepare pressed powdered samples, or we prepare fused bead samples. But there might be a situation where a customer would like to measure loose powder. And of course, the Primus 3 Next is not supplied with helium as a helium system. So it's only a vacuum system. But that's not a problem because Rigaku have made a special cell. And the cell is, it looks like this. So it's a plastic cup with a nylon filter. And you basically pull this forward. You place your loose powder in the cell with film on top. So the film is typically something that's supplied by Fitflex, for example, with a snap-on ring. So it means that this can be measured in vacuum because of this breathable filter that we have. So here I have an example of another cell, and this cell is also a plastic cup, but for very tiny samples. So the board here has different diameters. You have 10 and 20 millimeter, and you can place your small amount of powder in here with a film and a snap-on rim. Again, very easy to measure tiny samples. We may have a sample that looks like a grass. So this is an example of a grass sample. And it's very difficult to make a pressed powder from this kind of sample because it's difficult to compact, difficult to reduce particle size, and also not easy to compress because of the nature of the sample. So we also have what we call these discs, and the discs are basically supplied like this. You can peel off the backing, and it becomes like a sticky board. So you can place your grass sample onto this disc, and you now have a specimen for the analysis of a grass, for example, also measured in vacuum. Solutions that I wanted to show you. So there are many more that I can show you, but I think the important thing now is to show you a little bit of our software. And of course, how we can measure samples and so on. So let me switch over to the software. And I think you can all see that, right? Just let me know if you can't. Yeah. Okay, so this is our software. It's called ZSX Guidance software. So on your desktop, you have a small icon that looks like this. And basically, this icon that you see here, when you open it, will open up with a window that always shows you a spectrometer status. So this is a very nice system because at all times you have a control as to the working conditions of your instrument. So at the moment, you can see a robot system where everything is green and drop-down menus as well. So this is very nice and intuitive because before you start your daily measurements, you always have an overview of what your instrument status would be. You have different, what about if you want to measure a prepared sample? We have two ways of measuring a prepared sample. The first is doing a semi-quantitative analysis and a quantitative analysis. So you have two different icons here where you can start to develop methods, either semi-quantitative or quantitative applications. So these are very nice and user-friendly, so I can quickly show you how to develop a method. So if you wanted to prepare a semi-quantitative method, you could create a new application, or you can, I will show you an existing method. So here we have, for example, I just show you. So I have a waste sample, and the waste sample needs to be analyzed by semi-quant because we don't have a calibration method for it. So I called it refuse-derived material. And here you can see this very nice flow bar that I was talking about, or Paul was talking about earlier, where we can select and develop the method step by step. So for example, here we have a measurement of all the yellow elements as qualitative, and then we have the blue ones as fixed angles. So this is also a very nice feature in our software. So we can get better counting statistics for trace elements, for example, and we can look at mercury or cadmium for a longer period and count longer on the background. We also have the possibility to estimate the non-measuring components because it's waste. So waste is predominantly organic material with a lot of plastics and so on. So we can measure the Compton line to estimate the balance of the material. You can include the preparation of your sample. So there's a lot of traceability within the methods. You can define how you would like to report the results, if you would like to use sample spinning, if you would like to use a certain diameter. So the reporting can be created here. We can also use matching libraries, which is a very nice feature because we can create a better quantification by utilizing certified standards or secondary standards and creating our own fingerprinting or matching library, as we would say. And the very nice thing is you can search for the best match from the database that you've built up, or you can even specify it. These are the instrumental conditions that will be used and defined, so you don't have to think about what you want to do. It already makes the method for you. However, if you have a lot of experience and you would like to look at a certain element with a longer measurement time, you can go into each condition and change the settings. So you can go continuous or step scans, for example. Under fixed angles, you can define peak and background measurements. So you can make it better, but already the software has predicted the best measuring conditions for the best analytical line. What about a quantitative method? So it's also an example that I will show you. So here we can look at, for example, a pressed powder method. So this is an example, again, of a pressed powder method where we define all the conditions. And like Paul said, to develop the method, you run through the different steps. You define in the first section your components and samples and standards. You optimize your conditions. You measure your standards. You create the drift correction samples, and you compute the calibrations. And here you would, for example, define any overlap corrections or so on. So, of course, this we will teach you, of course, in the training sessions. But yes, this is the method. And once you have a method defined, you can also include check samples and limit ranges. So if you would like to report your results in a certain way, you have this section here. The check samples can be created and defined with lower and upper limits, for example. So now you have two methods. One is qualitative and one is quantitative. And of course, how are we going to measure our samples? So if you open the analysis section, you will open up with a batch analysis. And you can rearrange your tiling by pressing on this icon, and you will rearrange your sort of windows that you have open. So if you would like to create a measurement, you would double click on the blue line, and you can choose between the qualitative, which is semi-quantitative, or quantitative methods. And you also have a control. So this is where you would measure check samples, drift correction samples, or even measure your calibration standards. You can also create analytical tables. So, for example, I will show you now, I will just create some measurements. So this is a check sample. yeah, we have an intensity measurement, another check sample, and we can measure some quantitative analysis. Plus, we can create a semi-quantitative analysis, because this is another way where we can define a metal. So we have different models, and the models are divided into metals, powders, polymers, liquids, fusions, filters. So, of course, we can define, for example, an oxide powder. We can define the measuring range. We define the position. And here we have an input for the naming of the sample. Because Rigaku like a lot of traceability, we also have the operator. So here we can define the user who is creating the measurement. Here we have the different sections to create the diameters, which I showed you before. So we have the 10 millimeter, we have the 20 millimeter, the 30 millimeter, and the 35 millimeter. We can also define the measurement time. So we have standard short measurement time, which is 2 minutes. Standard is 8 minutes, so it's a longer spectral scan. And then a long method, which is 17 minutes. So this will be for the measurement from fluorine to curium. So remember, semi-quantitative is got a higher measurement of uncertainty, and we just would like to identify certain elements within the material. So this is why, if you would like to do a very short scan, we could, for example, just go for a 2 minute, and we could just identify the peaks. So now we also have an advanced section where we can define how we would like to report the samples, define preparation, and even define impurity corrections if there are any. Of course, the software has already built in impurity corrections, but we can even be advanced and define our own impurity corrections. What's really important here is the filing system. So our software has a very good filing system. So you can define the folders where you would like to save your analytical results. So you can, for example, structure it the way you like it. Of course, once again, you can put in some comments to your measurements. So here we have a batch of samples, and you can see we have a mixture. So we have check samples, we have intensity measurements for like a stability check. We also have, let's just do it like this. We also have some quantitative analysis and this semi-quantitative analysis. So as we mentioned before, we have two loading systems. One is for pre-evacuation of vacuum, and the other is for measurement of the sample here. So, of course, if I now say analyze, I will show you now the picking up of the sample. So here you can see the loader has now picked up one sample. And now I was a little bit too slow, sorry, but it will pick up a second sample now. So it will come. So here you can see, for example, in the automatic sample changer, you have the A, B, C, D that's shown here with the numbering system. So there it's picked up another sample. And of course, if you now look at your software, you will see that B1 is now being pre-evacuated with vacuum, and C1 is being measured. And immediately you can also see the progress of your measurements. So here you can see the progress of your measurements, and so on. So I will just upload the sample now because I just wanted to show you. So here's the coloring system to show you what's waiting, loading, measuring, unloading, and if there's any program operation. So if I now unload, then perhaps you can have a look again how you can create a batch of samples. But what about if you have a priority sample? So this very often happens. Then, of course, it's very easy to use the software and insert a priority sample. So we could say we would like to have this sample from a quantitative method. Here we would put in an input because the method was created like this. So this is a loss on ignition. And of course, we've now inserted a sample in the batch. And additionally, we can call it and say we would like to have a priority analysis. So here you can see the priority button over here. And then, of course, we've now prioritized this over the big batch of samples. Instead of stopping the measurement, we can do this and interrupt in such a way. Okay, so of course now let's give you an example of how you would look at your data. So of course, once the samples have been measured, you can close the windows because it's been completed, or if it's still measuring, you can also look at the data. So of course, here we have an icon which is called data processing icon. And here you can, for example, look at your results. And here we have an example of a check sample. So here you can look at the analytical result, or you can look at the intensity. Here you also have defined in the method some process parameters like a total. Here you can include process parameters for the cement industry, or if you are in the glass industry, you have different requirements. So those are some check samples, some examples. Stability tests, so this can be programmed to be measured how you would like it, so the program operation. And at all times, you will always have an indication of your spectrometer status. So you can look at the cabinet temperature, the main vacuum pressure that was at that particular measurement time, the gas flow rate of your P10 to your flow proportional counter, and of course for traceability, always the folder and the date and the time. So there's a lot of traceability. Additionally, you can always make comments in your data. So this is also very nice. And if you have a laboratory management system like a LIMS system, you can also create the results going through to a central point where you can pick up the results for the LIMS system, or if you are in a process plant, for example, like a QCX, and so on. Let's have a look at a semi-quantitative analysis so that you can just see, for example, how nice and easy it is to look at a semi-quantitative analysis. So here we have an example of a very simple qualitative analysis, and the sample contained a lot of organic material. So therefore, we can define our balance as, for example, a polyethylene, because it's a plastic, it's a polymer. So here you can choose, for example, the polyethylene. So once we have chosen it, we can calculate, and this is the balance of the material. But before we need to refine the measurement, it's always important for us to look at the spectra. So here you can see, for example, an example of some of the spectra. I won't look at all of them, but they are divided into heavy spectra and light spectra. I think the sample contains silica, so we can have a look at the silica. So yeah, that's an example of the heavy element spectra. Because it's a light matrix, we have a bigger content peak. Here we have the silica in the material. Yeah, so this is how we can have a look at our data. And what do we see from the calculation of the data? We have a result and we have a detection limit. So at all times, we always need to have a look at our detection limit and our analyzing depth. So this is very important in XRF, because very often the specimen that we measure could not be maybe thick enough. So we need to have an infinitely thick sample to measure. So this helps us to understand if our semi-quantitative result is good. What about if you would like to do look at the history of your check samples? Well, we have in the maintenance section an area where you can look at the history. So you can, for example, have built-in control charts into your system. This is very nice for industrial customers or a customer that has an ISO requirement, so that they can check their spectrometer before they measure samples. So here we have, for example, a very nice measurement where you can see that we measured this particular sample on several dates. So we've collected like 79 points over a period of time. And of course, you have a drop-down menu here to show, for example, the different elements. Yeah, so here you can see the calcium with a 2 sigma, and here you have the statistics on the measurements that we have completed. So, of course, this is very useful for us, because then we understand when it is time for us to do a drift correction. So this is one of the big advantages in XRF. We can keep our methods for a long period of time, provided we check them and provided that we do a drift correction. So once again, Rigaku have thought about how to make it easier for the customer. So once again, we have a very nice history to show you before we go to question and answer, is that if you have an analytical result, let's look at a quantitative result that we have here. So here we have an example of repeatability of a polymer sample where we can group the results. So very easy, like Excel, where you can group it, and then you can see, for example, what kind of standard deviation you would get in the ppm level of a polymer. So here you can see the lead was on average 98 ppm with a standard deviation of 0.5. So this is also a very nice section. If you look at just an individual result, at all times you can get the history here as to standard deviation, detection limits, and so on. So very intuitive and very nice way of looking at the results. Okay, so I would like to just share two last slides with you, and that is basically, I think you can see this now, yes. Of course, we not only provide you with an XRF instrument, but we also provide you with what we call a solution. So what does the solution mean? The solution basically means that we help you in terms of preparation of your samples, developing your methods, And if you need to comply to international norms, we help you with this as well. So, of course, our Primus 3 Next is compliant to the international norms. Once again, it is a very cost-efficient analytical instrument. And as you could see, it's very easy to navigate within the software. So even if you are not an XRF expert, it's very user-friendly. The analytical performance is extremely good because of our conditions in terms of crystals, detectors, the way that you are guided through the setting up of your methods. We can produce very reproducible analytical results due to many of the features that Paul and my colleagues have highlighted. We can define, for example, a standard operating practice for you to maintain your calibration methods so that you always can produce these excellent analytical results that we were talking. And of course, the question, of course, why Rigaku? As you can see, we have a very long history and we are a global history in company in X-rays. So the very first WD XRF was produced in 1952. So you can see that we have a continuous improvement, so permanently developing. And because we're Japanese, we have this Kaizen philosophy. Once again, you can see we have a very full range and of products available in the WD XRF line. And it's a very rugged and reliable industrial unit. So here are some examples of international norms. They're not all of them, but there are some of them that define what should be adhered to. And these are all some of the examples of where we are compliant to the international standards. So the ISO standards, the DIN, the EN standards, the ASTM standards. So yes, Primus 3 Next is the best for you, especially for industrial customers, even for research development areas. We can offer you very flexible packages. And it's really the best in the class for light elements. So you can even measure boron, for example. And one of the big advantages is, once again, with our tube above, meaning it's a very robust instrument, no breaking pellets, minimizing the risk of damaging your units. So yes, I think that's all I wanted to cover. I mean, there is a lot more that I can talk about, but otherwise we'll be here all day. So perhaps I can hand over to Gary and Paul, maybe, so that if we have any questions, we can tackle this.
Okay. Thank you very much, Carmen. Thank you very much, Paul. Before we carry on with any questions and answers, I'd just like to express my appreciation for your participation in this event and for providing the presentations, particularly for Carmen doing the live lab demo. I know juggling 2 cameras and a screen share is not an easy task to do that remotely, and to carry on presenting the way you did as well. So thanks once again for your participation in this. If anyone, as we said before, if anyone has any questions, please just type them into the questions and answers box, and we'll start going through those now. I've already collated a couple that have come through. The first one, not surprisingly, was how much does it cost? On that, I would say the price obviously varies depending on the specification, the final specification of instrument that you choose. And we won't go into specific pricing details publicly on this webinar. But going back to the presentation slides where we were talking about the product range, the Primus 3 is positioned in between the Super Mini 200 benchtop system and the Primus 4 series 4 kilowatt systems. It's very competitively priced, and if anyone wants to discuss in more detail the pricing of the system, then please feel free to contact me directly, and we will have that conversation. The second question we have is, what services does the system need? Perhaps I could pass that one on to Paul.
Yeah, I can try to answer this, although I'm not a service engineer, maybe not.
Perhaps Carmen. I'll between
Yeah.
the two of you.
But
Yeah, but the two of us, no problem.
yeah, so I think service preventive maintenance, I think, is the main thing to think about. So once per year, we would advise definitely a preventive maintenance, and I think this is really the main service that you need. And then there is, of course, also, I would say, it's not only technical service, it's also what service do you get after the purchase. And I think SciMed will come there in the first line, and then also we are supporting SciMed directly, so application support is also assured. So I think you're safe there.
Yeah, I think also the question, the context of the question might actually relate to what physical services does the instrument need to be plugged into for installation?
Yeah, so of course, coming from the application side, we always like to teach our customers what needs to be done correctly and properly.
No.
So, for example, yeah, those are some of the things that we can teach you as well. You know, there's very simple things that you can do, like, for example, cleaning the filters on the side of your instrument. Those can be done by yourself, you know. Or even making sure that your sample holders are clean at all times. You know, these are small little things that can make a difference in the lab. Yeah.
Okay. Yeah. And I would add, in terms of if the question was relating to the physical services that the instrument needs to be plugged into to operate, the external services,
Okay. Yeah.
we need electrical power.
We need electric power.
Oh,
We have
this
a
can
vacuum
either
pump.
be 3-phase or single phase. There is the option to have 3-phase or single phase power input. As it's a very high power system,
We need
the system
additional
requires
units.
external chiller for cooling water to the X-ray tube. Once you get to 3-4 kilowatt systems, the only way to cool the X-ray tube is with an external cooling system, and also P10 detector gas, which is a requirement for any XRF that has a flow proportional counter.
Unless you go for the sealed proportional counter, of course.
Yeah. So Rigaku offer the option for a sealed proportional counter, which means that you can remove the requirement for P10 flow gas. The other thing that Rigaku systems all work with is there's no requirement for external compressed air.
That's correct.
yeah, exactly.
Mechanical movements. Yeah.
The third question I have here is, I've always been told not to measure loose powders in vacuum. Doesn't this risk the sample blowing out and contaminating the XRF?
Carmen, I think this is one for you.
Yeah, so this is an example of what I tried to show you, you know, physically on the camera, but maybe we can go through it in theory. So we have what we call a powder sample container. And this powdered sample container looks like this. It has this nylon filter. You can place your loose powder in here with a film on top, and place the snap-on ring. So it's designed basically for you to be able to carry out a measurement with very high heat, like a 3 kilowatt or even a 4 kilowatt if you go for the bigger instrument. And it's really easy to measure this in vacuum. So it's designed for vacuum measurements. So when do you have this kind of situation? Sometimes some materials are really difficult to press, and therefore you can only do loose powder measurements, and very comfortably with this cell in a vacuum system. So it's very safe, and it's possible to use this cell. This cell is also provided in such a way that you can recycle it So you get supplied with additional filters, these nylon filters, so you can just reconstruct it. So it becomes a more cost-effective way of not having so many consumables in your laboratory.
Yeah.
Yeah. So that's one example. Yeah.
Okay, thank you very much. Final question I have here so far. The presentation, the first presentation mentioned a thick tube window. Would I lose sensitivity for the light elements using a thicker tube window?
Oh yeah, of course. You would lose some intensity, some sensitivity using a thicker window. Of course, we have with the ZSX Primus 3 Next a system that is really dedicated to heavy industries. That's really one thing I want to highlight again. So light elements you can analyze, but we must be aware that there may be a certain restriction in detection limits. But on the other hand side, if this becomes really very important in your applications, then we can of course directly advise the ZSX Primus 4, which is using a 30 micrometer window instead of a 127 micrometer window. And then you're a bit better for the light elements.
Okay. Okay, thank you very much. I don't see any more questions popping up in the Q&A.
I can see one question related to typical tube lifetime. If you run at 70% of the time at 100 milliamps, what's the typical tube lifetime on average?
I would say, Tom, it is, I would say that we are looking at 10 years. Yeah. Of course, tube lifetime has also its statistics, but I would say 10 years plus minus 2 years. It's a very rigid tube. And you can also say that there is a constant output of photons of the X-ray tube over a very long time. So drift of the X-ray tube is really low.
Yeah, there's
Yeah,
a lot of stability over this 10-year period. So yeah, we have some data for that. Yeah.
certainly from the SciMed perspective, the beginning of last year, we did some analytics on our installed base for a similar question that came from a sales project. And from our installed base, we found that we'd only had two tube failures from our entire installed base in sort of 10 to 12 year period.
Yeah.
One of which was a warranty failure on install, which was just an unfortunate situation with the manufacturing flaw on the X-ray tube, which was immediately replaced under warranty on install. And the second one where a tube had failed after approximately 9 years of operation.
Yeah.
Which is not,
But we then had a profile of systems that were running between 1 year old and 12 years old, all of which were still working with their original X-ray tube.
Yeah. That's good. Yeah.
Obviously,
Yeah.
our sample size is probably smaller than the data that Rigaku Corporation could pull together, but we anecdotally have a very good experience with the Rigaku X-ray tubes.
Yep.
Mhm.
Very reliable and robust. Yeah. So my Primus 4 in the service department is now 10 years, and the stability is still there. So yes, I agree.
Yeah.
Okay. I think that covers everything that's been asked. So I think we're looking at wrapping things up now. We're just about on our proposed time of 90 minutes for the webinar. So it remains with me just to thank everybody for attending. If you do have any feedback whatsoever, please do send us all of your feedback, positive or negative, so that we can implement any improvements that are suggested to these webinars that we host. And likewise, if anyone wants any further information about the products, or would like to discuss the products in any more detail, then you can get in touch with us directly at SciMed through the SciMed website, or by contacting us directly by email if you already know us.
Mhm.
So once again, thanks very much, everybody, for attending this session. And if there are no more questions, then I'd just like to say thank you very much and goodbye to everybody.
Thank you.
Yeah, thank you all.
Thank you.